Once again, I'm here with Taylan Atar. He's the proprietor and owner of Hills Tallarook, as well as the farmstore.com.au. And so this is both a farm stay as well as a goat farming operation. And because they're so far removed from Melbourne City, they're about an hour away, they're pretty much almost completely off-grid and self-sufficient. So what we're going to talk about today is a little bit about their solar array, their battery banks, their solar controllers, and just basically some of the electrical setup they have to feed the house. I'll get a shot just before I come back to Taylan. I'll get a shot of the solar array, or portions of the solar array that are on top of the outbuildings and the sheds that are here. So it's quite a significant and complex system, and I'll let him get into the details of power output, both from the solar panels themselves as well as the battery bank setup that he's got. He's got two separate battery banks, and I'll let him take it away. So take it away, Taylan.
Thanks, Jason. So you're quite right that we can't get power here, and even if we wanted to, we can't get easement rights from our neighbours, so we had no choice but to go down the solar path. There is roughly 65 to 70 160 watt solar panels on the roofs. They are all in series in groups of 3, so they're 24 volts each, which adds up to 74 volts all up, or 72 volts, my mistake. And we use the outback system to get the most efficient amperage out of the voltage that the sun's producing at the time. So today it's overcast, but if we go inside you'll see that the solar panels are working overtime. There are 2 sets of battery banks and 3 inverters here. 2 of the inverters run the homestead and the farm stay, all the pumps and swimming pools. We have another inverter and battery system about 2 kilometres away in another cabin. Both are interlinked by 16mm cable underground. However, there is still a significant voltage loss over that distance, so we use a step-up transformer down the other end, and depending on where the most amount of power is drawn, then the system pushes either way. So if there's a big load here, the system 2 kilometres away helps to top up this one as well.
Fantastic. So the battery banks are identical. The battery banks, in terms of their specifications, are identical, and they share load between each other and are balanced that way. And then you've also got a genset backup for those times when the you've also got a wind generator, I understand, in addition to your solar panels. And so at times when there's not enough wind or not enough sunshine shining to keep the battery banks topped up, then you've also again got a genset backing that system up as well.
That's correct. And you can feel that there's wind down here at the moment. Yet the wind generator is barely spinning, so depending on the levels of wind, other days there could be no wind and it could be still down here, but that will be going off its rocker. So it's probably not the best investment in the world. I actually put it in originally thinking that it might run the system and top it up a little bit at night, but for the cost, if I had my way again, I'd just put on an extra 3 solar panels. Right.
Okay. So is it a 3 kV wind generator, or what is the in theory at peak? What is it supposed to put out?
It's supposed to put out about 15 amp hours per hour.
Okay.
So it's not a big one. It was in its time 10-12 years ago.
Yep.
But there are far more better and efficient ones nowadays for the same price. You're right with the generator as well. It's a 10 kVA generator. It's all computerised, so it always works at full capacity when it comes on. It does a handover when it matches the frequency of the inverters. It releases the inverters, takes over the supply, and then each one of the inverters has a 100 amp charging facility. So, if the generator's working at 6 kilovolts, let's say, it'll use the other 4 kV to top up the batteries. If it comes on and it's only in trickle mode, then the full capacity of the chargers will come on to top up the batteries. So as soon as they charge up, it shuts down and hands back over.
Fantastic. So it's got its own onboard pure sine inverter,
yes.
And so it takes over from the inverters that you've got mounted near the battery bank, and we'll go and check those out now. So where's the wind generator? I don't think I got a shot of that. Oh, there we go. There we go. There's the wind generator right there. So that, yeah, even though it's got quite a stiff breeze, it's definitely not going too hard, is it, Tay?
No.
Great. So we'll go in here and we'll check out one of the main battery banks, as well as the inverter setup and the charge controllers, and all of his switch panels as well. So it's a pretty impressive setup. And I noticed last night, Taylan, maybe you can talk about the alarm system that you've got set up as well. If for some reason the battery bank gets too low in terms of its power levels, and the generator should kick on, and for whatever reason it doesn't auto-activate and auto-start, then you get an alarm, you get an automatic phone call on your cell phone to come out and check the system. In fact, that happened last night, so maybe you can talk a little bit about that as well.
Sure. So we are a meat business, so we have a lot of refrigeration out here, and our business is dependent on keeping all of that stuff going. So last night we had one of the inverters shut down, which was this guy here, which supplies one half of the homestead. The generator did fail for whatever reason. Normally it could be either there's no oil in it, or it's low on oil, or for whatever reason it just didn't start up. This little yellow box gives a pulse to the inverter to come on. If the pulse isn't long enough, sometimes it fails and won't start. It'll try once or twice to restart it and then shut down and go into alarm mode. When it goes into alarm mode, it's hooked up to a security company. As soon as the alarm's registered, they give me a call to say, hey, you've lost power at Tallarook, and we can come in and have a look to see what's gone wrong.
Fantastic.
So as you can see, there's 2 outback power systems here. There's a third older solar controller in here at full capacity. When all of these are going, we generate about 140, 150 amp hours.
Wow.
It is a fairly big system.
So are those Outback 45s? Is that what those ones are? Are they 45 amp each? What power rating are they? Because I know they do make quite a range. Outback do, yep. And these are Australian made, aren't they?
That's correct. So this one works at 80 amps.
Oh, it's an 80 amp.
And this one works at 60 amps.
Wow. Okay.
Okay, and this one works at 60 amps as well.
Great.
All right. And this is the little unit for the wind generator, which barely ever comes on. You can see 0 charge in the last 24 hours. But you know, all the solar panels work off fusing systems as well. The inverters, Celtronics, Australian-made inverters. All electronic components. They're very light.
Because you were explaining that your first inverters, obviously, with the older technology where they had hand-wound coils, extremely heavy, extremely unwieldy, took 2 men to lift them into place, whereas you were explaining with these, because they're completely electronic, they're extremely light and you can mount them on your own.
That's correct, and the old inverter, because it was coil wound, used to hum.
Yeah.
It was very noisy. You can hear if we stop talking, there's no noise to these.
Man, they are absolutely silent. I mean, it's just a very, there's a hint of electrical noise there, but it's really, there's nothing much at all. So, Celtronic is the brand?
Yes.
Yeah, they're an impressive looking bit of kit, and you can see the power cables coming in. They're all obviously fully insulated, and you've got isolation breakers for both the panels coming in as well as isolating off the inverters as well as the charge controllers. So are the charge controllers, are they actually daisy chained together, or how are the inputs from the solar array, are they actually split up over the separate charge controllers, or how does that, in terms of the configuration, how is that configured?
Well, this system basically grew as we grew. We originally started with a 2,000 watt inverter. This was going to be a weekender for us. I think that inverter lasted about 2 weeks before it blew up. And over time we've gone to bigger and bigger units. These were the state-of-the-art units about 2 years ago, so these are fairly current. As you can see, they're rated at 6,000 watts RMS, but these guys will peak at up to 18,000 watts for a certain period of time. They will peak at 18,000 watts, I think, for about 1 or 2 minutes, 9,000 watts for about 10-15 minutes, and 7,000 watts for 30, 40, 50 minutes.
And that's to handle spikes in load due to, for example, heavy load electrical motors starting up where they can draw triple their wattage on startup that they would under standard load.
Exactly.
And they have to be able to handle those shocks and spikes in terms of demand without actually shutting down the inverter. So
that's correct. So with these units also, they grew as we did. The PL60 was the first unit we installed. I think it had about 20 panels hanging off it. And then over time we've added another 20 and another sort of 30 odd onto that. So that's why the system's grown. The batteries are housed in this little compartment here. There's 24
I'll just step back and get a view of that.
Batteries.
So it's a big, it's basically a big enclosure that you've built. It's up off the ground,
yep.
As you can see. So it's
fully ventilated inside and out, so it can breathe.
Right. Okay. So these are obviously deep cycle, 2-volt. Big, massive, chunky batteries. Is it easy to lift that lid? Can we actually have a view in there, or could we'll maybe come back and we'll have a look at that a bit later on?
Yeah, it's locked at the moment.
Yep.
But that's about it.
Fantastic. So they're obviously not gel cell. They're flooded lead acid, are they?
That's correct.
So flooded lead acid.
Distilled water.
Right. Okay. Okay. And so obviously you have to do you have to check and keep them topped up. There's a bit of maintenance involved in that, but really because of the I guess because of the usage they get, there's not a lot of time where they're not actually being cycled.
That's right. And you know, when you're putting 125 amp hours into it very quickly over a short period of time, you can hear them bubble and boil. So we check them once a month, but probably once every 3 months is when we top them up with water. It takes about 30 litres across the 24 cells.
Wow, 30 litres every 3 months, so roughly 10 litres a month. Otherwise, obviously the plates inside get exposed, and then you lose capacity. And how deep of a discharge do you normally give them? Do you take them down to 40%, or what sort of discharge capacity do you try to? Because obviously the deeper the discharge, the more damage that can be done due to oxidation. So, what sort of charge cycles do you put them on?
I'm not sure of that. It's all computer controlled, and you can hook up a laptop and program it to whatever specs you need.
Right.
But we have a gentleman by the name of Rob McCauley that comes in once every 6 to 12 months and just double checks all the programming, and if there's software to be updated, he can just download it. There's a modem sitting around hanging off the system somewhere. So he just plugs it in, Wi-Fi's it, and updates the software. It's just an amazing system.
Fantastic. And was he the one that assisted in actually installing the system as well?
That's correct.
Fantastic. Well, maybe we'll chuck up a link to his, if he's got a website or something like that. We might be able to give him a bit of kudos as well, because it sounds like he's built a pretty impressive system along with your help. Because I mean, with your engineering background, obviously you knew what you wanted, and you just had someone who had access to the gear bring it in and set it up for you.
Yes.
Fantastic. Well, thanks, Tay. You've got a very, very impressive system. I'm a believer, definitely. You know, we had a great night last night. We had a dinner in the house, and you know, you said you had something like 150 downlights or something like that across the entire household. So there was there's a lot of lights running, and obviously because it's a farm stay, you've got guests staying in various different rooms using hot water, etc., etc. And system keeps up admirably, and when it's low, the generator just automatically kicks on. Keeps the batteries topped up, and no, it's a fantastic system. So thanks for showing it to us.
Thanks, Jason.
Cheers.